Hello, and welcome to Alchemy and Chemistry, Part 22. In today's video, I'll be doing a simple chemistry experiment, but with a unique twist. In today's experiment, I'll be combining blue vitriol, that is copper sulfate, with iron filings, which will yield copper. Now, this reaction's been done before, but in today's video, I'll be doing it in the presence of a magnetic field. The idea here is that when the copper separates from the sulfate ion and combines with the iron, releasing the iron and leaving the copper behind, perhaps the copper will take the shape of the magnetic field, or it might fall to pieces. We simply don't know. So, blue vitriol is the substance we'll be working with. There's also green vitriol, which will be a byproduct of this reaction, that is iron sulfate. Let's cover a few basics before we start to mix the chemicals. Copper is non-magnetic, right? Now, but it does react with magnets. If you drop a magnet through it, it falls a lot slower. Whoa, that sucker went right out there. Falls a lot slower than if it were just falling in the air. So copper does react with magnetic fields, but only when there's motion. When there's no motion, there's not much of a reaction, right? But magnets will always react or attract to the three elements: cobalt, nickel, and iron. So these are the ferromagnetic elements, but really all elements have some delicate interaction with magnetism. Stoichiometry. We've mentioned this before, but stoichiometry comes from the Greek word stoichion, combined with metry, meaning to measure, so it means measuring of the elements. And now, even though this chemical reaction is fairly simple, when you have a trade, that is to say one iron atom trades one copper atom in their position, it'd be like if I was trading a coin for a bullet, right? And you may have said, well, that's one coin to one bullet, fair trade. But the bullet weighs a little more than the coin, so we have to account for that in the measurements. And that's basically what stoichiometry is. And you have to go to the periodic table of atoms to figure out, okay, what weight is going to proportionally change the measurements as you weigh out the materials. So for this experiment, it'll be 159.6086 grams of copper sulfate, that is blue vitriol, combined with 55.845 grams of iron filings. Let's go ahead and get started. And again, in the presence of a magnetic field, what will it do? Maybe we'll have a new way to forge metals out of liquids without any heat, or maybe it'll just make a mess. Let's find out. So here's the magnetic field. It's influencing the iron filings. We've got a bit of a cool pattern going there, and I kind of stirred it around and got it fairly well evenly distributed. Here's the copper sulfate. I'm going to add water to the copper sulfate and try to get it to dissolve before pouring it into this magnetic iron matrix, and we'll go from there. Okay, so after warming some pure water and rainwater actually, and mixing in this 159 grams of copper sulfate, let's turn to this beautiful blue color, blue vitriol. And I realized that really I might not need 159 grams, but actually 260 grams of this substance, because when it's a very whitish, almost pale blue color, you've got the anhydrous form. But when it's a blue crystal, it's copper sulfate pentahydrate, which changes the molar mass and throws the weight off. So the weight's going to be a little off, but let's go ahead and mix some of this together and we'll get the reaction started. We may have to come back later and add more. Okay, so far this is pretty cool. I've mixed it back and forth a few times. We may have to do multiple stages of this to get the full process, but so far, look at what we have. The copper is already coating the steel, and it's retaining the shape of the magnetic field so far. That's pretty cool. It's taken on the shape of the magnetic field, but will it hold together? That's the question. Will it fuse together or not? So, I mean, I'm going to leave these magnets on here overnight, and we'll see what it's like tomorrow. After sitting overnight, the bottom edge has some black material down in it. So I'm going to go ahead and add the rest of the copper sulfate to account for the form that this is, which it looks more like copper sulfate pentahydrate. So to adjust for that molecular weight, I need to add another 90 grams. So let's go ahead and do that. And then we'll just let the reaction continue. Okay, it's been another hour or so. And even though this is plenty of blue vitriol for the stoichiometric balance, I think I'm kind of headed the wrong direction here. I think the majority of the displacement around the magnetic field has already happened, because when I remove these, it looks as though the shape stays, right? So, and I'm getting this sort of blackened discoloration in there. So, gosh, I don't know whether to let it continue to react or to just take it apart and decant some of this out. I'm leaning towards decanting this a little bit because it hasn't even changed to a greenish tone. I mean, it's mostly blue vitriol. So maybe we can do a control with the same solution and some iron filings without the magnets and see what we get. I would call this reasonably successful. I've diluted it many times to get the remaining blue vitriol out. The reaction was incomplete, so there's still some magnetism left here. I've removed the magnets, but you can see the imprint of the magnetic field, and it did retain a solid shape. It's not very strong, but it did form to a solid shape. And if you look at the perimeter, you can see the shape of the magnetic coils. You can kind of pick up on it. They're sort of like clam shapes. See, there's one, and there's the other. You can see this sort of like the cross section, like if you sliced an apple in half, you can see that little shape in here as the magnetic field worked its way around. And it did seem to form to that shape, which is really cool. I'm gonna put some water in here and let it sort of, I'm gonna try to get the remaining vitriol out, and then we'll let it dry. And we'll run a similar experiment to make green vitriol because, like I said, apparently the reaction doesn't need to go to completion to get the solid form. Had I let it stay to completion, I think it might have damaged the structure. So I was just kind of going on an instinct there. Here's a comparison sample. We're just gonna do an excess of iron filings and a diluted solution of the blue vitriol so that we can get green vitriol. We'll just let that sit without magnets and see what kind of a reaction we get. Okay, so I think the repeated rinsings was a bad idea. It started to weaken the mixture, and I think what happens when it's diluted like that, when it's diluted and you do multiple rinsings, instead of doing the strong reaction where iron is created, iron swaps position with copper, it sort of just started oxidizing it. And so we were getting a lot of like black particles, and instead of being blue or green vitriol, it just started to turn black. And that's not what we want, because it started to weaken the mixture and change the color from a bright copper color, which you saw not long ago, to this dull color here. So apparently the repeated rinsings isn't a good way to do this. I may have to repeat the experiment, but you can still see the magnetic field patterns in there, and it did sort of hold together. Okay, after sitting for some time, I think it was about 2 days, you can see here we're getting green vitriol, and because there was an excess of iron in the bottom, it converted all of the blue vitriol to green vitriol. Unfortunately, you get other dirt products in there. You get rust and iron sulfide and other kind of gunky things. And in the blue vitriol, I kind of noticed that it's more blue towards the bottom than it is towards the top. It almost has a little more of a greenish tint at the top. I think probably it's trying to layer out, because perhaps the iron sulfate is a little bit lighter than the copper sulfate, so it almost has a little bit of a layering effect. Here's a comparison of the copper-coated steel that didn't have a magnetic field. As you can see, it's not cohesive at all, and if it dries, it's just going to be a powder again. But the components, the copper-coated iron that was exposed to the magnetic field, took on a solid form and retained some of the magnetic field lines in its shape, and it's quite a bit stronger compared to the other one. I mean, it's not strong as metals go, but it did form a cohesive lump there. Even got a little bit of strength to it. So I think we're onto something.